Hello everyone, welcome to Data Fuse Analytics, your go-to channel for all the things related to artificial intelligence. Today, we are diving into exciting world of conversational AI. Chatbots such as ChatGPT excel at fluency in conversations, but they often stumble when it comes to domain-specific knowledge or real-world updates. But fear not guys, in this particular video, we are unveiling the secret sauce, that is Retrieval-Augmented Generation or RAG for short. Well, RAG is the game changer that bridges the gap between fluency and domain specificity in chatbots. And guess what? In this video, I'll be your guide on the journey to building your very own chatbot using RAG. Yes, you heard it right. You will learn how to converse or chat with the system based on the documents which you upload. But before we get our hands dirty with code, let's first understand the system flow. I have prepared a simple yet comprehensive flowchart that outlines the entire process. This flowchart will serve as our roadmap as we navigate through different modules of our chatbot. So grab your notebooks and let's start coding. So let's implement the first step, that is taking input document from the user, then saving the document and then loading the document. So here you can see I have created a new folder named as RAG custom chatbot. So I'll be creating a new Python file app.py. Here I will be importing Streamlit and then we will set page config. We will set page title as Data Fuse Analytics Develop Custom Chatbot, and then we will give an icon to this page, that is this icon, the LangChain icon. We will set the title for this page, that is we will simply copy paste this stuff and we will copy paste this good cute icon. Now we will write uploaded files equal to st, that is representing Streamlit, st dot sidebar dot file underscore uploader, right, and here label will be equal to upload files. Type for in this project we will be having only PDF file. You can add here txt or you can add here EPUB and so on, but for now we will play with only PDF files. Then there is a parameter whether to accept multiple files or not. So we will be accepting multiple files and we will be keeping it as true. If not uploaded files, then we will write here st.info please upload documents here, and then we will write here st.stop. Let's save this file and run this file in terminal just to check whether we are currently in right direction or not. So in order to run this particular app.py, we will write streamlit run RAG. In this we have app.py. This is the first error that we have got, that is invalid syntax. Let's debug this. So here page icon, it has to be equal to, okay, I have again saved this file. Let's run this again, streamlit and this. Okay, so this is our home page and we will be uploading our file here. Okay, I think we are good to go now for second step. Step 2 is, after the document is loaded, we will split that input document into small chunks, and then we will generate embeddings from these chunks, and finally we will be storing these embeddings into vector storage. So let's implement. So I'll declare a variable conf chain conversational chain, and then we will define a function. So let's call the function as configure retrieval chain, and in this we will input uploaded files. Okay, now we need to define this particular function, that is configure retrieval chain. For that I will be making a new file, chat-with-docs.py. Now let's import all the necessary packages first. Now that we have imported all the packages which are required from LangChain, so let's define a function configure retrieval chain. The input to that will be uploaded files. Now we will be inputting, we have the provision of inputting multiple files, right? So docs will be a list. We will be storing the file in this temporary directory. Let's create a folder, that is rag for file in uploaded files. The file path will be temp file path equal to os.path.join. We will provide temporary directory first and then the name of the file.name. Now we will open that particular file. So with open temp file path as write binary as f, and then we will store this particular file in this file, the content of the file, get value, then docs.extend. Here we will have to write a function called as load document. Now this function will load the entire document, that is in temp file path. Now we need to write this particular load document. For this load document we will be again creating another file which is called as utils, or you might rename it as helper. So let's code this particular function, that is a load document, in utils for now. So definition function load file document, and then the input will be temp file path, extension will be equal to we will be using this pathlib library, so import pathlib, and we will be using to find extension of this particular file, pathlib.path. Input will be temp file path dot suffix. So this will be the output of this will be the extension of file. Suppose we are uploading PDF, then the output will be PDF, and so on. Now as we are dealing with PDF documents, right? So here we will be using PyPDF loader from LangChain library. So from LangChain dot document loaders import PyPDF loader, and we will be using this PyPDF loader in this loaded. So PyPDF loader input will be temp file path, and docs will be equal to loaded.load, and then we will return docs. Okay, now that our functionality to load this particular document is ready, let's import this. So from utils import load document, so we can use this load document here. So in this way we have implemented a full-fledged functionality for document loading. Now we have to write a script for retriever. So retriever will be equal to let's call function configure retriever. The input will be document, and then we will be having a chain, that is configure chain, and in this the input to this configure chain will be retriever, and finally we will be returning this chain. Now we have to define functions called as configure retriever and configure chain. Now let's define these two functions in here. Let's define the first function, that is configure retriever. Input will be docx. The first step is we need to write for text splitter. So text splitter equal to recursive character text splitter. We need to write here chunk size. For now I am writing 1500 and chunk overlap, which will be equal to 200 for now. Then splits will be equal to text splitter dot split document, and in this the input will be docs. Now we need to create embeddings. So in order to create embeddings, we will have openai embeddings. In this we have to pass openai API key, and we will be defining this openai API key in a new file for confidential purpose. So here I will write openai key.py, and then I will define a variable here openai AI API underscore key, which is equal to, for now I am writing xxxs, and we will be importing this here. So from open underscore AI underscore key import, we will be importing this particular variable openai API key, and we will be passing this to here. Now alternatively you can also use Hugging Face embeddings, and you can use any model from that. Now let's define vector DB. Vector DB will be doc array in memory search dot from documents. The input will be splits and then embeddings. So we will be using this doc array in memory search. It offers advanced indexing, comprehensive serialization, and a unified Pythonic interface. Additionally, it efficiently handles multimodal data for tasks like NLP, computer vision, and audio processing. So now that our vector DB is ready, we will be defining a retriever which will be equal to vector DB dot as underscore retriever. Here search type will be equal to MMR. Here MMR is maximum marginal relevance, so we can apply diversity based re-ranking of documents during retrieval to get results that cover different perspectives or points of view from the documents retrieved so far. And then there will be some search KWARGS variable arguments, and here there will be K, which will be equal to 5, fetch underscore K, which will be 7, then include metadata, we will set as true, and then we will finally return the retriever. Now that we have defined this configure retriever, we will define configure chain as well. So let's define this configure chain. So definition function configure chain, input would be retriever. So the params would be, we will define a dictionary here. The LLM is LLM. Now this particular LLM, it has to be some kind of LLM. Let's suppose ChatGPT or GPT 3.5 turbo. So LLM equal, we need to define this LLM. So LLM equal to chat openai. First parameter is model underscore name, which will be equal to GPT 3.5 turbo, and we will set temperature for now as 0 and streaming equal to true. Finally, we need to define the openai key. So openai underscore API underscore key, this will be equal to openai API key, this one. So this will be our LLM. Then the retriever will be equal to retriever. The significant part or the important part is memory. So memory will be this particular memory. Now this memory we haven't defined yet, right? This capital memory. Now we will be defining this capital memory now. In order to define this memory, let's go back to utils and we will write the code for memory here. So there are different kinds of memory which are available in LangChain. We will be using conversational buffer memory. So from LangChain dot memory, import conversation buffer memory. So we will define another function. Let's suppose initialization of memory. In this we will return conversation buffer memory. In conversational buffer memory there are few arguments or parameters we need to pass, like memory underscore key. Let's set it as chat underscore history. Then we have return messages as true. Then we have output key as answer. That's it. So we have defined this memory. Oh, okay, just one more thing. Memory, we need to call this function, right? Init memory. That's it. So we will be using this variable here, in Chatbot docs. So from utils import load document, as well as we need to import memory. Now where were we? Here. Then we will set verbose. Verbose will be set to true. And finally max tokens limit we will be setting as, let's suppose, 4000. I think that's it. We will be using these two functions. Now let's go back to app. Now what app will do, it will set these all titles and all. It will upload the documents, and then it will configure this retrieval chain. First it will load the document, then it will split the document in this, and then the chain will be configured. Let's run this. So we are getting this error. Let's try to solve this error. Name configure retrieval chain is not defined. Okay, so we haven't imported this configure retrieval chain. Now let's again try to run this. Again we are faced with one error. So here, instead of using this round bracket, we need to use this curly bracket, as we are defining this dictionary, right? So let's rerun this. Let's solve this error. Include metadata, it will be a colon. Okay, let's stop this and let's rerun this. Okay, now I think we are error free. Let's upload file. Let's add a folder, that is temp dir, and then we need to run this particular file. Let's upload this file. Uploaded file has no attribute get value. So to solve this get value error, we need to change the casing. So here it will be lowercase. Let's try to rerun everything. Let's upload a file. So we have got here invalid API key because I have written here xxxx. So I'll write the actual API key here. So I have added my account's actual openai API key. Let's try to rerun this block of code. Let's upload a file. Okay, I think the processing is complete. Let's check the actual command line. So yeah, everything is done. So we are able to split the file, we are able to generate embedding and then store in memory vector DB. Now we are at the final stage. In this step, we will take input from the user or input query from the user. We will develop a retrieval module which will communicate with vector storage and the conversational chain, and then the user will get an output. We will define something called as avatars, which will be human for user, and then we will have AI for assistant. If length of memory dot chat underscore memory dot messages is 0, so here is 0, then we will display a message, that is st dot chat underscore message assistant dot markdown as ask me anything. Then for each message in memory dot chat underscore memory dot messages, we will print st dot chat message. We will have here avatars of message dot type. Now we will define assistant. Assistant will be equal to st dot chat underscore message, and here it will be assistant. If user query equal to st dot chat underscore input, and we will have here placeholder, that is type your query or message here. Then we will execute this. So st dot chat underscore message, we will have user dot write user query. Then we will have a container. Container will be equal to empty. We will initialize it at empty, st dot empty. Then we will have a stream handler. Stream handler will be streamlit call back handler. So for this we have to import this streamlit callback handler. Streamlit dot external dot LangChain import streamlit callback handler. Now we are almost done. The input will be container to the streamlit callback handler. Now with st dot chat message assistant print, here we are running this conversational chain. Response will be equal to, you will be using this conversational chain dot run. In this run we will be defining a dictionary wherein the first argument will be question. Question will be equal to user query, whatever the user will ask. And in chat history we will give here memory dot chat underscore memory chat underscore memory dot messages. And then finally we will have callbacks, which will be equal to stream handler. And finally we will display, we need to display the response, right, from our chatbot. So if we have got a response, then simple, that is container dot markdown and here response. So final step is done. We have defined avatars, we have defined assistant, we have defined and used this convolutional chain, and we have executed this on user query, and we are storing all the chat memory messages. So let's run this entire thing. Let's upload a file. It is running. Some error. Let's import it from utils. So from utils import memory. Let's run. Again let's upload this file. Okay, now the chatbot has asked us, ask me anything. So can you summarize the paper for me? We have got an error. We will solve this. So this particular chain is coming out to be none type. Now let's check if this configure chain is returning something. So this is not returning something. This is not returning actually anything, and that's why we are getting none as return type. So here we need to return conversational retrieval chain dot from underscore LLM, and then we need to pass here params, which we have defined here. Let's save this and let's rerun this. Let's upload a document. Let's input. It is running. Now it is thinking. Now we have got the output. Let's ask him another question, like who are the authors of this research paper? The authors are Ashish, Vaswani, Ki, Jacob, and so on. So in this way, we have actually implemented a fully functional chatbot using Retrieval-Augmented Generation using LLM. So that's it guys. If you have watched this video till now, give a like to this video, comment on this video for your feedback, and subscribe to the channel. Bye bye guys, and take care.